to Pantech E Learning. Today is day 3 of Autonomous Vehicle Masterclass. Today we are going to discuss about the visualized sensor coverage and detection and tracks. So this is the topic today. So first, what is bird's eye plot? So this is the diagram of bird's eye plot. So it's look like this only. So alright. So this example we are going to look how we can use this bird's eye plot in MATLAB to show some cool stuff happening around the car. So imagine you are sitting inside your car. You want to see what's happening around you. So that's exactly what we are going to with this plot. So first of all, we have some information about the lanes on the road, and you know those lines that divide up the lanes. So we will draw those lines on our plot to give us a sense of where the car is driving. So here we have two types of sensors on our car. One is the vision sensor, another one is the radar sensor. So these sensors help the car see what's around it. Mainly these vision sensors are like the eyes and radar sensors are like the ears, but they help the car understand its surroundings. So we have got some data from these sensors. After the vision sensor have spotted some objects in the lanes or in the road. So and the radar sensors have detected the others. So we will show these objects on our plot, bird's eye plot. So we are also tracking some of these objects over the time. That means we are keeping an eye on them as they move. So we will draw some lines to show where these objects have been, where they are going like that. So there is a one really important object. We want to keep an extra close eye on that. So it's a big truck or a fast car. So whatever it is, we will highlight in our plot to make sure we don't miss it anyone. So all this information being shown what's called bird's eye plot. So it's like a special map that helps us to understand what's happening around the car. So mainly this bird's eye plot is set up in the way that car is in the middle. So and the things around it that is shown in a different direction. So this is a bird's eye plot. So today we are going to talk about the one example based on this bird's eye plot. We are going to explore how a car can understand its surroundings using some pre-recorded sensor data and tracking the results. So imagine you are driving a car and you have some special sensors installed on it. These sensors helps you see what's around happening in the car. So first we have the lane information, and another one we need the vision objects and radar objects and positions and some velocities and covariance, some matrices and labels on the tracks. So most important object here, there is a one object we particularly interested in. So it could be something a big or something moving fast. So whatever it is, we are paying extra attention to it to find out that moving object, most important object by using this. So what we are going to do with all this data and lessons, we will use some special kind of a plot that is called bird's eye plot to visualize it. So to visualize all the things. So this plot is like a bird's eye view of the world around the car. It helps us see where the things are related to the car. So that is what the whole example is. So this is the plotting tracks, and another one is the final output. So this is the final output of our session. So in the first step of configuring the bird's eye plot, so we are setting up the some coordinate system. So imagine you are looking at the scene from above the car. We are going to create this view with the axis, x-axis that pointing upwards and y-axis that pointing to the left. So we need to decide how far we want to see. In this example, we are focusing on what is in front of the car. So we are setting some limit. We are setting the x limit and y limit like that. So we are setting the limit to 90 meters ahead of the car, and we also want to see what's around the car. So we will set the limit to 35 meters on the each side. So this means our bird's eye plot will show us a square area with the sides of the 70 meters and depth of the 90 meters in front of the car. I will show you that one also. So for that we need the MATLAB software here. You can convert the masterclass into 1 month internship program, especially the autonomous vehicle masterclass into 1 month internship program. So this internship program, you will be getting 30 days of live recorded sessions and 30 days of PPT's presentation for the download and 10 plus project source codes, especially for the autonomous vehicle. So you can convert this masterclass free 21 days masterclass into 1 month internship program. So you will get 1 month internship certificate also. And also you will get a participation certificate and 90 days of access to that courses. And you will have 4 hackathon live sessions. So these are all advantages if you are converting your free 21 days masterclass on autonomous vehicle into 1 month internship program. So the actual price is 1,999. We are offering a 799. So use this registration link to join as an internship user. Don't miss out this exciting offer. And one more thing, we are offering exclusive 3-in-1 internship offer. So with this 3-in-1 internship offer, you will get EV design masterclass and battery management system masterclass and autonomous vehicle masterclass. So you will be getting 3 big masterclasses under this 3-in-1 internship offer. And also, you will be getting 120 days of live plus recorded sessions because here you have 3 big masterclass, EV design, battery management system, and autonomous vehicle. So 120 days of live recorded sessions and 120 days of presentation for the download, and you will be getting 10 project source codes. So project source is nothing but autonomous vehicle related project, EV design related project like that. And you will be getting 3 internship certificate, not 1 internship certificate. You will be get 3 internship certificate under the EV design, battery management system, and autonomous vehicle. And also you will be getting 1 year validity to the courses. And also you will have weekly hackathon sessions, hackathon live sessions in Zoom. And also you will be getting assignments and mock tests. So these are all the advantage. If you are internship user, you will get these advantages. So the actual price for this 3-in-1 offer, the actual price is 4,997 and we are offering a 1,199. So don't miss out this exciting offer. Use this registration link to join as an internship user. Again, I'll tell you. So this free 21 days masterclass on autonomous vehicle, you can convert this masterclass into 1 month internship program. So open the MATLAB software. This is the MATLAB software. I am going to use the editor page. Okay. So this is the editor page here. We are going to do some programming for our bird's eye plot. So visualize the sensors and detection and tracks. So first, we are going to mention the name. So BEP, that means a bird's eye plot equal to bird's eye plot bird's eye plot, open the braces. This is the x limits and comma. So open the square bracket. So here we need the 1 comma, and here open the square boxes, that is a 0 space 90 and give comma, then y limits. So y limits is about to minus 35 to plus 35, minus 35 space plus 35. So close this braces. So put the semicolon. So this is the first step. So here we are going to create the x-axis and y-axis. So that means our plot, our bird's eye plot will show us a square area with sides of the 17 meters. So minus 35 minus of minus 35, 70 meters. So 35 meters on each side and depth of the 90 meters in front of the car. So this gives us a good view of the scene around the ego vehicle. That means eco vehicle. So once we have set up the coordinate system and defined the scene limits, so we are ready for the next step. So that means which is to add some sensor coverage and plot the data onto our plot, onto this bird's eye plot. So now the second step. So what is our second step? So this is the cap. Once I finish, I will explain this line line by line. Give the space and coverage area plotter. Open this one, this PEP, comma. So here we have to give the color of our one. So that is the face color, comma. Next one is the, we have to mention that color. So here I am going to mention the blue. So this one is blue, and we are also mentioning the edge color also. So that is the edge color. So this edge color is also blue. So this is the edge color. Edge color, and this one is also blue. Finish this one and put the semicolon. So next, the cap 2. Cap 2. Give the space and coverage plotter. Coverage area plotter. Open the braces. The same BEP. Give comma and face color. So this is the face color, and here the face color is red. So here the face color is red. And again put the comma, and this is the edge color. So this is the edge color, and this one also red. Put the semicolon. Again we need cap 3. So cap 3, give the space and coverage area plotter. Open this one, PEP, put this column and the face color. So here the face color is also red. I will tell you once I finish this one. So this is the red, the column, and this is the edge color. This one is the edge color, and edge color also red. Next, put the semicolon. So here the coverage area plotter. So this is the second step of configuring the bird's eye plot. So here we are going to create some plotters for visualizing our specific types of data. So mainly this plotter. So this plotter, it helps us display the information like the sensor coverage area and object detection and tracks and lane boundaries and object trajectories like that. So here this is the coverage area plotter. So mainly this plotter is used to visualize the coverage areas. It helps us see when where the sensors can see in the environment. So next one is the, so next one we are going to cover the vision sensor and 2 for the radar mode. So we are specifying the colors of the coverage area to differentiate between them. So that is why we use the face color and edge color. So this face color parameter sets the color of the coverage area, and the edge color parameter, it sets the color of the boundary of the coverage area. So this face color, it sets the color of the coverage area, and edge color, it sets the boundary of the coverage area. So this is the main difference between the face color and edge color. So next is the step 3. So here we are going to load something. So we are going to load the sensor configuration data in a MATLAB format. So use this sensor configuration to plot the sensor coverage areas, and also it uses the shaded blue coverage area, and radar modes are stated in the red color. So here we are going to load the sensor So we are going to load this sensor configuration mat data, configuration data dot mat file. Put the semicolon, and again we are using the for loop. So for I equal to 1:3. So here the plot coverage area, plot coverage area. Plot coverage area, open the braces, this cap of I. Once I finish this program, I will explain you each and every line. Open this square bracket and sensor parameter. Sensor parameters. Open this one, put the I dot x, comma, sensor, the same parameter of I dot caps y. And then close this bracket. So close this bracket and move on to the next step here. So again, the sensor parameters of I, range and yaw angle, and also the field of view. So we are going to give additional information here. So the sensor parameters, so of I, and I dot, this one is the range, and comma, this one is the sensor parameters of I. This one is the yaw angle. This is the yaw angle, comma. Again, the sensor parameters. Open this one. So I and dot FOV. That means field of view. So close this bracket and put the semicolon. So this is the, here we are going to use the for loop. So mainly, first we have to load our data. So this load sensor configuration data dot mat file. So this load, it consists of the sensor configuration data from the file named sensor configuration data.m file. So this file contains information about the sensor, that means positions, ranges, and yaw angles and field of view like that. So here we are using the for loop. So for I equal to 1:3. So we use a loop to iterate over each sensor configuration. So this cap of I, it refers to the coverage area plotter, so that we created earlier. So we are using this object to plot the coverage area for each sensor. So next one, we are using the sensors parameters of I dot x and sensor parameters I dot y. So it represents the position of the sensor that related to the axis region. That means x and y coordinates respectively. And next one is the range. So sensor parameters range in the sense it is the range of the sensor that indicating how far it can see. That is the range. And next one is the yaw angle. So this yaw angle is a yaw angle of the sensor related to the x-axis, that is specifying its orientation. Next one is the field of view. So this is indicating the angular range over which it can detect the object. So inside this loop, the plot coverage area function is called to plot the coverage area for each sensor. So mainly this function takes the sensor's positions and range and yaw angle and FOV as the input parameters. So this is what this line, for loop, and here we are going to end our for loop here. So this is the end. Now I am going to give the title of this plot. So before I am going to run this one, right, I will show you in the run. So this is the code visualize. So this is running now. Here we have some error. Okay, wait. So sensor, yeah, here I have the error. Now I'm going to again this one as a run. Let's see. So this one is the range and yaw angle and sensor parameter of field of view. Now I'm going to run this one. So the small spelling mistake also will get error. Yeah. So now we got the output. So here you can see there is no title of this plot. So I am going to give the title. So for that we need the title function here. So just give the title. Open this one. So what is our title? So this one is the bird's eye, bird's eye plot. This one is the bird's eye plot. So this is the bird's eye plot. Now I'm going to again run this program. So here you can see this is the bird's eye plot. This is the title of this plot. Okay. So now I'm going to add few more steps. That means adding the time step here. So now we are going to load the another data. So for that we need the load function here. So load, open this one. This one is the bird's eye plot. The eye plot example data.mat. Give comma and data to display here. So this one is the data to display and put the semicolon. And here I am give the time step is about 125. So give the space. This is the 125. Put the semicolon. This is the time step. Again, we are going to add some more information here. So that is the data time step for the data to display. So I will show you that one also. Wait. So here I am having the code here. So this is that code. So here we are adding this load. So here we are adding the bird's eye plot example data.mat file. So that one is data to display. So in this display, we are visualizing coverage of a vision sensor and two radar sensors moved around the ego vehicle. So this is that function. And again, so we are going to give the time step. That means the skip to the 125th time step where there are 5 vision detections and multiple radar objects and tracks. So here we are going to extract that data from this data for time step to data to display. So that is why we are mentioning that one. So next we are going to add some more information. So that means plotting the detection here. So for plotting the detection, we are using the plot detection function. So this is that function, plot detection function. So it will create the plotters to display the recorded vision and the radar detection. So that is why we use that name here. Now this line, so this BEP plotter, so this line, it creates a vision detector plotter and stores in it a texture name BEP plotters dot vision. And the display name, the parameter, it sets the display name of the plotter to the vision detection. And next one is the marked edge detector. So marked edge color. So this one is the marked edge color. That is the marker. So this parameter sets the color of the marker edges to the blue one. So this is the color of the marker edge. And again, we are going to the same way we are going to create the radar as a vision like. Next one, we are going to creating the radar detection plotter by using the BEP plotters dot radar. It creates a radar detection plotter and stores in a texture name that is called BEP plotters dot radar. Next one, we are going to give the display name of this one, that is the radar detection, and marker edge color is the blue. Next, we are going to plotting the vision detection. So the same way we created as earlier, here the vision objects post contains the position information of the vision detectors objects at the specified timestamp. Next, we are going to plotting our radar object post. So that means we are going to plotting our radar detection. So this line plots the radar detection using the radar detection plotter. So this radar objects post, it contains the position information of the radar object, radar detector objects at the specified time step. So overall, this segment it creates a plotters for the displaying the vision and radar detection, and it assigns them to structure the future use. So let's run this one. I will show you. So I am going to copy this time step to the up to the radar objects. So copy and paste it here. Now run this program. Okay, so I got an error. So here I'm going to run this. So before I run this, I'm going to finish this program completely. Give a few seconds. I will explain this one from this BEP plotters. Now we are going to plotting the sum tracks and we are going to plot the most important objects. So for that we need additional information about this one. So first we are going to creating the track plotter. So by using this track plotter function. So this line it creates the, so this is the track plotter function. This line it creates a track plotter for displaying the tracked objects on the bird's eye plot. So here the display name, the parameter, it sets the display name of the plotter to track the object. And next one is the history depth. So this is the history depth. Mainly this history depth parameter specifies the number of track updates. That means history to display. It keep on track updates to display in case of it's set to the 10. Next one, we are going to creating the plotter for the most important object. That means MIO. So that is the most important object. And now its line creates a track plotter for displaying the most important object on the bird's eye plot. Here the display name. So this display name parameter sets the display name of the plotter to most important object. Next one, the marker face color. So it sets the parameter, it sets the color of the marker face to the black. So here I am mentioning that black. Now we are going to again plot our tracks. So this one is the plotting the tracks, and this line it tracks the tracked object by using the track plotter that we created earlier. Next one is the track positions. So this one is the track position. So it contains the position information of the tracked objects. And next one, track velocity. It contains the velocity information of the tracked object. And next one is the track covariances. So this one, it contains the position covariation information of the tracked objects. Next one is the track labels. So mainly this label, it contains the labels assigned to the tracked objects. So next we are going to plot our MIO, that means the most important object. Mainly this one is MIO position. It contains the position information and information of the most important object. Next one is the MI velocity. So this velocity contains information of the most important object. Next one is the label, as a label assigned to the most important objects. So overall, this code segment, it creates a plotters for displaying the tracks of the tracked objects and the most important objects on the bird's eye plot. And then plots to plot the tracks accordingly. So it helps to visualize the movement of objects and track their positions over the time. So that is why we use this one. Now I'm going to run this whole program here. Yeah. So here you can see it exactly detects the objects. So this is the yellow color is the lane boundary. So lane boundaries also it's detected. And next one, this black color is the most important object. So this is the most important object. And this one is the history. And this triangle, sorry, this square is the tracked object. And this small circle is the radar detection, and this one is the vision detection. So this is the way you have to visualize your recorded data and detect from that recorded data also. So this is all about this day 3 of autonomous vehicle session, and visualize sensor coverage and detection and tracks. So this is the way you are going to create your own plot and detect the track and detect the any objects from the sensor data by using this program. You can convert the masterclass into 1 month internship program, especially the autonomous vehicle masterclass into 1 month internship program. So this internship program, you will be getting 30 days of live recorded sessions and 30 days of PPT's presentation for the download, and 10 plus project source codes, especially for the autonomous vehicle. So you can convert this masterclass free 21 days masterclass into 1 month internship program. So you will get 1 month internship certificate also. And also you will get a participation certificate and 90 days of access to that courses. And you will have 4 hackathon live sessions. So these are all advantages if you are converting your free 21 days masterclass on autonomous vehicle into 1 month internship program. So the actual price is 1,999. We are offering a 799. So use this registration link to join as an internship user. Don't miss out this exciting offer. And one more thing, we are offering exclusive 3-in-1 internship offer. So with this 3-in-1 internship offer, you will get EV design masterclass and battery management system masterclass and autonomous vehicle masterclass. So you will be getting 3 big masterclasses under this 3-in-1 internship offer. And also you will be getting 120 days of live plus recorded sessions, because here you have 3 big masterclass: EV design, battery management system and autonomous vehicle. So 120 days of live recorded sessions and 120 days of presentation for the download, and you will be getting 10 project source codes. So project source is nothing but autonomous vehicle related project, EV design related project, like that. And you will be getting 3 internship certificate, not 1 internship certificate. You will be get 3 internship certificate under the EV design, battery management system, and autonomous vehicle. And also you will be getting 1 year validity to the courses. And also you will have weekly hackathon sessions, hackathon live sessions in Zoom. And also you will be getting assignments and mock tests. So these are all the advantage. If you are internship user, you will get these advantages. So the actual price for this 3-in-1 offer, the actual price is 4,997 and we are offering a 1199. So don't miss out this exciting offer. Use this registration link to join as an internship user. Again, I tell you, so this free 21 days masterclass on autonomous vehicle, you can convert this masterclass into 1 month internship program. First, you have to examine the provided bird's eye plot and displaying the sensor coverage as this program and detections and tracks, and you have to detect the lane boundaries around the ego vehicle. So next one, focus on one type of the detection, any one, or a vision or a radar. So this is any one of the sensor. So displayed on the plot, and identify and count the number of detections of that type present in the scene. So this is all for internship user task.